Good evening. Good evening and welcome to Biodiversity Days. I'm Paula Ehrlich, the President and CEO of the E.O. Wilson Biodiversity Foundation. The theme of this year's The theme of this year's Biodiversity Days event is Half Earth. E.O. Wilson's call to save half the Earth for the rest of life. And we're almost halfway through 2 full days of Half Earth Project Program Partner and Half Earth Council public lectures, roundtable discussions, and films about how the Half Earth Project will bring this grand vision and important goal to life. And we're having a blast. I hope that you'll continue to participate tomorrow at Duke's Nicholas School of the Environment, and really every day, as each of you find your own unique way to fold the hope of the Half-Earth solution into your own lives, to your own sort of holy grail. Tonight, with thanks to Jim and Kathy Stone, who are here in the front, I'm honored to introduce our keynote speaker, Edward O. Wilson, who will give the James M. and Kathleen D. Distinguished Lectureship in Biodiversity, Half Earth, How to Save the Natural World. Following his lecture, 3 members of the Half Earth Council, Louie Psihoyos, Thomas Lovejoy, and John Seager, will join Ed for a panel discussion and Q&A. And then Ed will introduce a special friend, singer Paul Simon. With thanks also to our co-sponsors, listed on the slide, NatureServe, Discover Life in America, the Nature Conservancy, Duke's Nicholas School of the Environment, and the North Carolina Museum of Science. Let me introduce Ed. Edward Osborne Wilson is generally recognized as one of the leading scientists and thought leaders in the world. He's acknowledged as the creator of 2 scientific disciplines, island biogeography and sociobiology, 3 unifying concepts for science and the humanities, biophilia, biodiversity studies, and consilience, and 1 major technological advance in the study of global biodiversity, the Encyclopedia of Life. He's received 149 national and international awards in science, literature, conservation, and public service, and 42 honorary degrees from universities in the U.S. and Europe. Of significance, he received the Crawford Prize, which is the Nobel for biology, from the Swedish Academy of Sciences for his research on island biogeography, which is the foundation of modern ecology and conservation science, and the foundation for Half Earth. Among other national and international prizes, Ed has received the U.S. National Medal of Science, the Hubbard Medal, the International Cosmos Prize of Japan, and 2 Pulitzer Prizes in literature. He's currently honorary curator in entomology and university research professor emeritus at Harvard University, chairman of the E.O. Wilson Biodiversity Foundation's Board of Advisors, and chairman of the Half Earth Council. Ed, welcome.
Thank you so much. Thank you, Paula. Thank you all for coming. I think we have a great movement going, a lot of people involved in it. I think we're going to be successful, and I appreciate your coming and joining us during a celebration of the early stages of our drive to bring an important new idea, I believe, to the field of environmental science. Let me begin with a brief introduction to biodiversity. As the living part of the earth, the immensity of its size, its majesty, and how little we know about it. My aim is to present you with a radical view of Mother Nature, a new definition of wildlife, and the conception of Earth as a little-known planet. Then I'm going to give you an updated report from recent research on the deterioration condition of biodiversity and what we can do to bring that to a halt and why we must bring that to a halt. We can reverse climate change. That is physically possible. But species extinction is really, really forever. When Mother Nature walks away, she will never return. So just what is biodiversity? Biodiversity is defined as the collectivity of, this sounds technical, heritable variation. That is, inherited forms of variation, what the units of it are, and so on, from individual to individual, species to species, and so on. It can be applied to the fauna and the flora and on down to the microorganisms of any space that might start from your backyard to your hind gut. Yes, you have a whole marvelous microbial fauna. We all do down there, or to the whole world. And species are, in fact, the pivotal level of in the practice of biodiversity conservation. They are part of a hierarchy, the main part of the system we recognize of biodiversity overall. And may I have the first slide? Is that a possibility? I should have checked to make sure it comes on all right. Let's see if that happens. Ta-da! Okay. The three levels of biodiversity are the ecosystems at the top, the ponds, the patches of forest, the piece of coral reef, and the middle level of the species that make up each of this ecosystem, and the bottom level are the genes that prescribe the traits that define the species that make up the ecosystems. Each species has been uniquely adapted to its environment by natural selection. Each interacts in a characteristic manner with other members of its ecosystems, and the evolution and geographic history of a species can be traced, and in most cases, its present status can be evaluated rather rapidly and with exactitude. I'm now going to run through just a few slides to give you a feeling for natural environments and the amount of biodiversity at the species level. Next slide, please. Or maybe I have I do. I'm a Harvard professor. I am always well prepared. And, you know, I sort of half expect for the light or the microphone to fail while I'm talking to give you a demonstration of Harvard technology. Anyway, I want with this pie diagram to bring home quickly the point that while our attention is on plants, 370 flowering plants, 375,000 northern species, and on vertebrate animals, mammals, reptiles, amphibians, birds, fishes. 63,000 known species. The bulk of biodiversity is in the invertebrate animals, the little things that run the world, I like to call them. And that's the main part that remains undiscovered. I'm not gonna, you better turn, here we are. I take from my colleague, Quentin Wheeler, who made this slide, or thought of the idea of representing the number of species in different major groups of organisms by a single individual belonging to that group and making its size proportionate to the number of known species on Earth. And so we have a gigantic beetle for the insects and so on. Moving on quickly, I wanted then to just go through with a very quick overview scan of some of the variation and start with the nematodes, the roundworms. You may never have seen one. They're visible to the naked eye. They are the most abundant organisms on Earth. It's been said that if you remove all solid matter on the surface of the Earth, except nematodes, you could still see the shapes of all those objects from the nematodes left behind. That's how abundant they are, and yet most people have never seen a nematode or a roundworm, as they're called. Continuing on, I hope. Yeah. But all of this simply dwindles to next to nothing in the diversity and the biomass of bacteria. We don't even have a good first estimate of how many species of bacteria there are because we've scarcely begun to explore it. This is still a largely unknown part of the biosphere with great challenges for its discovery ahead. Bacteria, I might add, make up the bulk of what is called the deep biome, which is a layer of organisms, mostly bacteria, but nematodes we now know occur in it, that start somewhere around a meter below the Earth's surface, both on the ocean floor and on the terrestrial floor, and goes then down for more than a kilometer and lives off of the reduction of sulfates. In other words, it eats rocks. They eat rocks. They do not depend in any way on photosynthesis. We could burn off ourselves. I don't want to start thinking about that possibility in today's. Well, anyway, we could burn off the entire surface of the Earth. The end of life on Earth, as we think would be, but it would go on in the deep biome. There are greater weight of bacteria alone in that deep biome than in all of the vegetation on the surface of the Earth. It is largely unexplored. And moving on quickly through this brief little survey, viruses, we're just beginning to get an idea of the variety of viruses, and believe me, they do more in the total biosphere than give you a bad cold. There are viruses everywhere. They may be the most abundant quasi-organisms. You don't want to call them organisms, then quasi-organisms in the planet. We know that a vast number exists, for example, in the sea where they are predators, like packs of wolves on a bacterium called Prochlorococcus. And Prochlorococcus is responsible for most of the photosynthesis going on in the sea. And yet, that bacterium was not discovered until the 1980s because it is ultra-microscopic and beyond the power of most ordinary microscopes used in the laboratories. And the same is true of the viruses, that this is an entire world that we just discovered exists. And we haven't really begun to study it and calculate its meaning for biological diversity and maintenance of life. Only recently, in the last couple of years, a eukaryotic organism, that's one unit with higher cell properties, was discovered that constitutes an entirely new phylum comparable with, say, mollusks and echinoderms and so on. It's the Picozoa. And like the aforementioned microorganisms of the sea, too small to be seen except by very special methods. And yet it may teem, and we don't know anything about Picozoans, their biology and so on. And not knowing that much about such a large span of the Earth's microbiology, of course, we don't know much at all about the genes, the genome. This is the total DNA spelled out for a bacterium. And here is, this panel shows, well, it's a mess. But what it is an actual photograph of human DNA. But keep in mind, as you look at that, you have to have over 1,000 panels like that spread out to include all of human DNA magnified to that degree. So that's what we're also facing at the level of the gene in our exploration of biodiversity. So why am I showing you all of this? Well, for one thing, I want to get your focus quickly on to the species as the basic units in the study of biodiversity. And particularly from the scientist's point of view, but increasingly, as we hear of species extinction, of the view from just our ordinary lives. Ecosystems, of course, are very important to know and map them in detail. From a scientist's point of view, however, they are mostly subjective in classification. They change from one year to another more rapidly than do species, far more rapidly than the species in them. The genes of constituent species, in turn, are, of course, also the fundamental level we would go for. And scientists have found that the reading of the genomes, all of the genes of a species, is a powerful tool for scoring and measuring biodiversity within a species or an ecosystem. Yet, most biological research, and especially with reference to the environment, requires intimate knowledge of, to repeat, the species, especially its genetically determined traits, which give it a place in the ecosystems and, of course, are of immediate biological reference to humans. The identity of a particular DNA segment, or even half of the genes themselves, tells us actually very little about the anatomy, physiology, or behavior of the organism, and even less about the role in, among other species, and part of the ecosystem to which it belongs. The rate at which major natural ecosystems, the ponds again, forests, coral reefs, and so on, the rate at which they are disappearing, shrinking and disappearing, is, of course, extremely important. It tells us a lot about the loss of biodiversity, but the rate of species extinction, how fast species are dying off, disappearing forever, tells us a great deal more and with a lot more precision. At this point, I'm going to give you another little quick slideshow in which we will visit the tropical rainforest briefly, mainly for the purpose of giving this map, which is in which the black area is the rainforest, shrinking of a few years ago, but shrinking very rapidly, and with it an immense part of the Earth's biodiversity at all levels. Yes, and we're just beginning to explore it, especially in the canopy. The canopy, the treetops, that often in mature rainforests go up 80, 100 feet, are unexplored territory. It's like a different world. There's a whole different fauna. There are whole different plants that live on the branches of these trees, of the epiphytes. And there are epiphytes of epiphytes. They're called epiphils and so on. But I'm droning on, and I want to move on to tell you how exciting it is to, for young scientists now, preferred that they be athletic, or to get into the canopy and start exploring it as though they just entered a new continent. This is one of our graduate students from Harvard who, well, I showed one going up. Wait a minute. No. No, this is skipping around on me. Never mind. What I was showing was one of our graduate students climbing a rope up after he shot an arrow with a lead line over a high limb, pulled down to tie a rope, and he goes up. We don't expect graduate students to do research like that, but when they get up, then they can move around in the foliage for a while and learn an immense amount. But we're moving on quickly to show you how we're doing it. One of the best ways of doing it is with a building crane. It takes the investigator up in a gondola and lowers them or moves them around. There's the actual thing. That's the first one built in Barra, Colorado. And here is the researchers coming down to study. For the first time ever, they can come to the outside of the, there we are, to the, where people have never been before, come outside to the outermost foliage of the canopy without having to climb out on a limb or anything, but come up and see it as actually is undisturbed. And I have had the thrill of traveling around in a gondola like that. If you ever have a chance, if it ever becomes a popular tourist attraction, I recommend it strongly. At any rate, but I did want to move quickly on to tell you that where we are right now, in the temperate zone, you have a similar unknown world in the layer of the soil and leaf litter. And this was illustrated for me by the New York Times. Pray to the gods that are for the health and freedom of the New York Times. At any rate, did this for me to just give a sense of what you would look like, just condensed, if you wanted to see the immense amount of biodiversity in Central Park, and you took a cube of soil and looked up close. That's the ensemble that you would see, the kind of creatures you would see. Of them, most of the species would be known now, but the biology of them, we would know very little. The creatures of this is a very small section of rainforest floor, once again, to show how abundant things are in this category of life. Now to the heart of the biodiversity problem. Oh, but before I do, I did want to say one more thing to you, and that was this is the way to get kids into studying biology, natural history, science, is to make clear to them that if they even went into their backyard and knew where to look, they would be finding new species. And if they went up to some ecosystem like a decaying stump right here and began working on it after the tree was cut until it completely decomposed, they would see an astonishing variety of species of organisms that feed on the dead wood, that feed on each other, that feed on the fungus that grows there, and so on and on. That's a world filled. I just use the larvae of flies, but it's group after group of organisms could be equally denoted. And you could spend a lifetime of research on one decaying stump. And you could make discoveries, not just new species and so on, but you could make discoveries of how ecosystems are formed and how they change through time. Just sit there in a camp chair with a suitable drink by your side, a notebook and a camera, and you could make a career without ever moving away from. All right. And one last thing connected with getting kids into science. Kids love this stuff. And I'm going to show you, if you just turn them loose, empower them, tell them they can make discoveries, ask them to find out what they can find. Rachel Carson said something like that. She said, take a child down to the seashore, give them a pail and a little shovel, and tell them to find what they can and bring them back and talk about it. At any rate, this is me at the age of 13 in Mobile, Alabama. And I'm already a dedicated naturalist, as so many kids are when they're given a little freedom in their interesting environment. And I'm looking in the vacant lot where at the age of 13 I discovered the first fire ant discovered in the United States. And this invasive species then spread out. We lived on a few blocks from the docks where the first colonies came in from Argentina in cargo, and I just caught it. I made my first scientific observation. Of course, I didn't realize it. I knew what I had, but I didn't know what it was until a few years later. And just to show you that good naturalists never grow up. That's me, photographs taken when I wasn't looking by my friend and co-worker Bert Holdobler. And this is a park in San Jose. And I'm in the process of collecting an ant, a kind of ant, where in this spot I've discovered 3 new species foraging up and down. And I might have gotten more, but the police came. Now to the heart of the biodiversity problem. First of all, what is the status of the Earth's species? And what has been the achievement of all those trying to save them until now, the heroes of the global conservation effort? The number of surviving species diagnosed on this planet and given a Latinized name by taxonomists, that is, we have the way of identifying them and beginning research on their biology. The number on the planet has recently passed 2 million. The actual number, however, of species, and now we're just talking about more advanced species, not including the microorganisms like bacteria. The actual number is the estimated number is about 10 million. 2,000 species known by science, most of them just by a name and a few facts about what they look like. 2,000 known, 8,000 remaining undiscovered. At the present time, we have the capacity to do it in this neglected field of taxonomy and field exploration. We are describing 18,000 new species a year on average. And in case you're wondering, I have personally described 450 new species of ants in my erratic and otherwise perhaps inefficient career. So at this pace of exploration, just simple elementary exploration of the living world, the living part of the planet, species, the global census at this rate will not be completed until sometime in the 23rd centuries. Now, let me ask, can we afford to wait? I'm going to show you now a quick series of slides to illustrate why, no, we cannot afford the wait. We have to get this show on the road and actually explore the living part of the environment and understand what the damage is. Slash and burn destruction of tropical forests, especially bad in tropical America and in Asia especially. And the activities of humans illustrated by the points of light that you see from a circling space vehicle. Shows how, now I'm coming to the crux of the half-Earth proposal. In the 1960s, Robert MacArthur of Princeton and I, we were young professors, got together and devised a theory of island biogeography, which is based substantially on the rather exact relation that you find between the number of species that are sustainably on an island. We were using island to the relation to the area of it. So later we saw that this could be applied to conservation science in that you can think of the shrinking forest or the closed off part of the river source as a shrinking reserve, and you get this relationship by which you can estimate how many species you can save in a dwindling environment by how much you reduce the area that makes it sustainably possible. And here I'm now going to show you quickly what is happening. I'm going to go through this quickly. This is the Philippine Islands in different years. We are starting early in the century. We are going now year by year. The green, of course, is a forest on the Philippine Island, one of the richest in the world. And now that's what we have left. We see the same thing in the we see the same thing in the Atlantic forest of Brazil, in which Stuart Pym of Duke University is doing so much excellent work, research and remedies here at Duke, and well, it doesn't need commentary as to how fast the forest has gone. Now we come to that relationship and the source of the estimate that we can save 85%. That's the figure you arrive at, but there are so many variables that come into it. This has got to be an approximate figure, but it would be very high. I'm fairly sure somewhere up around 80% of all the species in the world can be saved by, if we could put aside 1/2 of the Earth. I'll come back to that shortly and give you a few more figures and notes to tell you why this is possible. Now, let me ask the next question. How successful have the conservation organization, of all the conservation organizations in the world, how successful have they been in staunching the rate of the amount of species extinction? Species extinction now has soared to over 100 times the rate before the coming of humans. That's a lower figure, and it's accelerating and going up onto 1,000 times. If that acceleration rate, which we impose on the natural world by our disturbances and removal of it, then by the end of the century, I think it's a fairly comfortable estimate that we will have lost half of the species on Earth. And that means a lot of the ecosystems, it would be a drastic reduction of the amount of the rest of life, the variety of the rest of life. Then how successful have the conservation efforts at slowing that down. Then, among the terrestrial and freshwater vertebrates that we know best, birds, again, mammals, reptiles, amphibians, and fish, only about 20% of the species classified in the red list of the International Union for Conservation of Nature on a scale of vulnerable to critically endangered, only 20% have been slowed in their and stopped in their descent on down to the final category of extinct. Now, that's a terrible record. I mean, we're in the situation of a surgeon in an emergency ward treating an accident victim with a team around her and with using the absolute best methods they have available, and she has slowed the hemorrhaging of the victim by 20%. Congratulations, the patient will be dead by morning. There are two parallel and equally important potential solutions to the extinction crisis. The first one is by taking, if we could have it, if it would work, one decisive, fast-track step. And that's where we come to Half-Earth. Because habitat destruction of natural environments is by far the primary destroyer of biodiversity worldwide, species extinction can best be ended, or almost ended, by the expansion of nature reserves around the world. If the protected areas of the world's land, now at 15% roughly, and of the sea, now about 5% protected, if we could raise those to 1/2 each, the global extinction rate of species would be lowered, as I said, by 80% or more. The exact figure you come out with, we don't want to be too exact in something like this, but the exact figure would be 85%. And, you know, we could, if it's anywhere close to that, we could greatly increase that by including in the half set aside the hotspot, where most of the known endangered species are located, in that half that we've set aside. Then we really would get to a point where we're back to the very slow extinction rate that occurred before we invested the globe. And that rate is approximately one species going extinct per million species per year. In other words, I like to put it, if we could do that, then we can rest easy. Then we would pass on most of the remaining biodiversity to the rest of the world. This is the Half-Earth solution, and the curve that I just showed is how that's calculated off of the empirical data, of real measurements and experiments made, checking it. This is the generalization of that, but that's on a solid base of both theory and experimentation. Now, the second avenue, and equally important, that's the long-term avenue we have to take, is, and say after, suppose we succeeded in setting aside half the world that way, then we have to go into the long-term care of the species there and in the unprotected areas. And that is to, the second method is to revitalize taxonomy. The description and classification of species, the discovery of species with field work and expert attention to all the species out there in different ecosystems, and begin a serious census of the world's biodiversity, which we have not gotten. I said 80% estimated, still unknown. So, and with taxonomy, we need immediately scientific natural history. That sounds old-fashioned, but really that's going to be a large part of modern biology. working out the scientific natural history, all of the adaptations of these species and how they interact. Then, back and forth, from genes to species, through species to ecosystems and back, we need to create new competent disciplines, technologies, ways of working. We need to create a real community ecology with studies, real, deep studies of ecosystems and conservation science. We have to know what biodiversity still exists and where in order to save it. Right now, the world databases are pitifully incomplete. Right now, we are about to experience what I think is going to be one of the next big things in the history of science, biology and history of science generally, the kind that poses huge, deep problems on the order of nature and invites new ways of thinking. That's what leads to great science. And that field is going to be ecosystem studies. And in order to understand these extremely complex systems, ecosystems, which are, I think, conceivably the most complex systems that we can know in the universe, the human brain not accepted, ecosystems are going to be it, the big challenge. We've got to know enough so that if you see a species plucked, you know what the reverberations are going to be in that ecosystem. If you see an alien species introduced, you've got to know what the reverberations are through the remainder of the ecosystem. And for young people, and I know there are a lot of them here, if you're thinking of going into scientific natural history or any aspect of ecology, field biology so far, you are not entering an old-fashioned branch of biology and science. You're not going to have these sort of out-of-fashion molecular geneticists looking down their nose at you. You are going to be the inheritors of a future big thing in science. I wish, as I've often said, my friend, oh, to be 70 again. So I'd like, therefore, to close with the concept of what I like to call the Linnaean Renaissance. Such an extension, an application, looks to this new revival of what was once mainly 19th century and early 20th century biology, revival with new technology, with new ideas, which new intensity of purpose. What was faded was shaded by the golden age brilliance of molecular biology. Now is about to return, and I'd like to see the best of our young people in science and technology prepared to enter it. Ecologists, taxonomists, and conservation biologists have made impressive strides in technology and mathematical model building, and now I want to see them put real flesh behind all of this. We have now all the work the conservation organization has reduced, as I believe I've said, reduced the extinction of species only by 20%. That's not enough. We have to change that. Environmental science in the United States and elsewhere today is not ready for this kind of a challenge. It's in a bizarre situation. The study of the environment to the present time and the public attention of what has to be done and what kind of science needs to be done is virtually limited to the non-living part of the environment, to climate change, to pollution, to the exhaustion of non-resourceable sources, and so on. Of course, that has to remain vital. But now we need to broaden it and actually take up the living part of the environment. If we do not The consequences of this imbalance are going to be deep and unpleasant. They will prove in the long term to equal those we now are faced with in climate change as the world, the living world, unravels. They cannot be reversed. Mother Nature, as I said, if she walks away from it, will never be seen again. Now I'd like to finish by reading the final paragraph of my book, Half Earth. We should forever bear in mind that the beautiful world that our species inherited took the biosphere 3.5 billion years to create. The intricacy of the species we know only in part, and the way they work together to create a sustainable balance we have only recently begun to grasp. Like it or not, prepared or not, we are the minds and the stewards of the living world. Our own ultimate future depends upon that understanding. We have come a very long way through the barbaric period in which we still, unfortunately, live. And now I believe we've learned enough to adopt a transcendent moral precept concerning the rest of life on this planet. It's easy to say, do no further harm to the biosphere. Thank you.
We're going to be joined here with Tom Lovejoy here to my right, your left, professor of George Mason University, and he serves as a senior fellow at the United Nations Foundations. He coined the term biodiversity, which I used to think that Ed did, but anyway, so you coined the term, and you worked with the interaction between climate change and biodiversity for more than 20 years, and you serve as a key member of the scientific core of the Half Earth Council. And to my left, your right, John Seager is president and CEO of the Population Connection. Before joining, he's with the U.S. Environmental Protection Agency. You just got out of there in time, right? John has published op-eds and articles on population growth in a number of popular magazines like Huffington Post, Global Post, Our Each Reality, and he's a member of the Half Earth Council as well. John will help address the obvious questions on population control that arises on this. And myself, I'm a filmmaker. I did a film called The Cove and one on the loss of biodiversity is called Racing Extinction. Thank you. Thank you. I worked for National Geographic for about 20 years, but I worked for the dark side for about 4 years. I worked for Disney, and they had it was the biggest annual report in the world. All far-flung places you'd have to go to photograph cruise ships and theme parks and the movies, the movie business. And I remember at Burbank at the headquarters, they had a saying from Walt Disney that said, "Remember, this all started with a mouse." And now as I think about this, if you're successful setting half the Earth aside, this is all your epitaph is going to be. This all began with an ant. The question I have, though, Ed, is it's all about scale. How do you? Obviously this is a huge undertaking. How do you, first of all, create the awareness? I mean, you probably, how many people have read Ed's book here? Quite a few, yeah. I mean, the latest one on Half Earth. Inspired me. How do you? But there's not too many people read anymore. How do you create the awareness that this is going on, and then more importantly, create the action? What's your idea? How do you scale up this idea of half Earth and start to implement it? What's the grand vision? How do you go about doing it? You're awful quiet over there, Ed.
You're looking at me.
I am. We'll start with you.
Well, sure. There are a variety of things to do. And one of them is embodied in a little phrase. I coined it just to sort of make it recognizable. That's the Linnaean Renaissance. A Renaissance is the revival and the return to glory of something that was once of great esteem and human activity, but faded. And that's a general term. And so we need to bring back this now relatively unpopular, maybe seemingly old-fashioned science of taxonomy, and with it natural history. That's going to be central out there in the field. We have all the instruments we need for high-flying surveys of the size of the ecosystems and the quality of the air and so on. But we're only going to find out the diversity that's there by boots on the ground. Now that's what I'm talking about. The return of field biology and of the classification and all that it goes with it to understand every species in turn. Now the other, of course, the way we can bring this to public engagement is it's got to be obviously through education. And here we have, I think, a distinct built-in advantage. I have a feeling about public education that we're going about science education especially all wrong. And we have a tendency to, speaking to a kid that's bright and coming along, saying, oh, you've shown an interest in biology. Huh? Well, I'll tell you what, here's what you've got to do if you're going to be a biologist, I mean a real professional biologist and make interesting discoveries. You've got to know some chemistry. So, first of all, I tell you what, let's learn a little bit of chemistry. And oh yes, listen, to really have a good grasp of chemistry, and I don't want to burden you too much with this, but you're going to have to learn some physics. I know, physics is mathematics and nature, and yet you don't particularly like mathematics. Whether at this point the kid, is wondering about what the chances are of becoming a star quarterback. Whatever. Anyway, that way of thinking, the primacy, the disciplines, and then leading up to the more complex and uncertain disciplines of biology is wrong. It needs to be reversed. You should start the child in biology. That's true also of young people in developing countries who have the ability, the opportunity to go out and start exploring their environment. And kids love it. I mean, when you empower them by telling them that they can go out and make discoveries on their own, maybe find a rare species or something especially interesting, and that's science. You engage them. They're doing something on their own. They don't have to memorize or learn principles yet, but they can be affected in the way of thinking and the interests they have for the rest of their lives. I think among virtually all of the fellow biologists I know, like Tom Lovejoy, for example, began that way. We were turned loose in the woods and told to go find something interesting and so on. So teaching in that sequence with teachers, people who can be mentors for introducing children to interesting aspects and then begin to fill the details as they mature a little bit more and more. But however we do it, we've got to get a better kind of education for science. I've written a book, not selling a book, but if you want to know just how I've got it figured out, 42 years of teaching at Harvard. Now you might think that really disqualifies me, but anyway, This is the way I've expressed it in letters to a young scientist. And I've told him, among other things, and I've had mathematicians who agreed with me, is if mathematics sort of repels you a little bit and makes you worry a lot, forget about it. You can learn a tremendous amount of science before you have to learn how to do, if you ever have to learn how to do more complex mathematical operations. So, short answer to your question, let us reinvigorate the fields of biology that we have neglected in a renaissance. And along with that, let us work hard to get a better approach to science and science education by our children.
John. We were talking earlier, and you were saying that you've been talking to universities, like several dozen in the last year here. Give us some hope. What makes you think that this is possible?
Well, this semester I'll be speaking on 28 college campuses. The amount of energy that I see out there, the interest is beyond anything I've ever seen before. The question I get from students over and over again, and I always pass out surveys, is, we know things are a mess. Tell us what we can do about it. Tell us what we can do about it. And there's a slide that I always use from Dr. King, who wrote eloquently on the challenges of overpopulation. And one of the things he talked about in this particular presentation was the difference between knowledge and awareness. And how do you move from knowing something's wrong to acting on it? I'm just old enough to remember the colored-only bathroom signs here in the South, and the North had its own set of equally pernicious problems. Somehow, Dr. King and many others managed to move us from knowledge to awareness. Some people say economics is a dismal science. I spent a lot of time in a much more dismal science, namely political science, and I don't mean to introduce that nasty subject into such a nice evening, but I will mention that the former Prime Minister of the UK, Harold Macmillan, was once asked what brings about change. He gave a four-word answer. He said, events, dear boy, events. An event occurred on November 8th last year that seems to have tapped a level of energy and drive to change things that I haven't seen in 50 years. And I'll just close by saying anger is an understandable and human emotion. I think what we're trying to do and what I'm trying to do, and I hope what we'll all try to do, is to try to figure out how to not necessarily let go of that. Sometimes there are things worth being angry about, but try to focus it in ways that we can actually accomplish things and work together. There is a level of grassroots energy out there right now, and I don't think there's anybody up here who's going to make it happen. I think it's going to have to be people within every community who step forward, and it's starting to sound like a campaign speech, so I'll shut up.
But I want to continue on one thing, though. You were talking about, everybody talks about population. We're at 7.5 billion people right now, soon to be 9 billion people. There's a middle class right now in China that exceeds our middle class here. There's going to be the equivalent of 3 more American middle classes by the mid-century. And if they're consuming the way that we're doing, you can't have this. We're not going to have nature as we know it, because the biggest problem with habitat destruction isn't just the people. It's the crops, the cropland that we've set aside for animals that we're going to raise food for, that we're in turn going to eat. So how do we? How can you address? And by the way, I think you were writing too that you said it's not the impoverished countries that are the problem. In Chad, with the average family size is 6 people, they use about as much energy as American family does, about 1%, right? So what's the problem with having an overpopulated? Besides that, it's going to be a crash the resources over there. What's the problem with having? Are we going to be able to scale this up to accommodate 9 billion people by mid-century?
About a dozen years ago, when the UN did a population projection, and they do them for 10-year increments, 2050 out to 2100. Nobody really looks past that because there's no data. You'd have to know how many children your great-grandchildren are going to have, so you really can't go out any farther than that. But a dozen years ago, the UN estimated, according to their medium projection, that there would be 9 billion people on the planet by 2100. Last year, when they revised those numbers, actually in 2015, they increased that 2100 estimate to 11.2 billion. That's like getting up one morning and suddenly discovering the entire Western Hemisphere plus Europe plus Oceania. It was increased by 2.2 billion. So the estimates are going up dramatically. And that's a huge challenge, and without getting too far into it, it has to do with the fact that we're engaging in vast amounts of wishful thinking when it comes to the less well-off parts of the world, instead of investing in what we know works. But to your broader point, back, in the 70s, two scientists, Paul Ehrlich, who was one of our co-founders, and John Holdren, who just finished up an 8-year stint as Obama's White House science advisor, developed a very simple formula, and there have been many more complex iterations since then, but it still is a useful tool. It's called the IPAT formula. Impact, mainly environmental impact, equals population times affluence times technology. In the case of population, the higher it gets, the more impact. In case of affluence, to date, it has always led to that same factor. I keep hoping that at some point the affluence curve will bend and people will tire of getting more stuff, but there's not much evidence to support that. The interesting one is technology, because technology can cut either way. Technology can exacerbate problems or it can ameliorate problems. I would submit, for example, that if you listed the top 5 technological advances of the last, say, 1,000 years, antibiotics, the printing press, Netflix, things like that, I don't know how you would not put modern contraception on that list. It is an absolutely transformative technology. Just a couple of very quick numbers around that. When Dr. Wilson was born, world population was about a quarter of what it is today. You talk about half Earth, we've added 3 Earths worth of population compared to what we had when Dr. Wilson was born. I think you're, 23 now, I guess? And that's the bad news. The good news is when I was born, which was right in the middle of the century, 1950, the average woman on Earth had 5 children. Today she has 2.5. And that's due to a number of things, but it could not possibly have happened without that technology. So that technology can have a transformative effect in either direction. The challenge, the final thing I would say on this, is that under the best foreseeable scenario, it's going to take century after century after century to undo the damage, or even begin to undo the damage that we've done over the last 200 years to the natural world. And that's why half Earth is so important, because no matter how fast we proceed, it's going to take a very long time to restore anything resembling balance. And if we don't do this, it's just flat out going to be too late.
Tom, how do we scale this up?
So first of all, before I get to that, just let me just underline the importance of Ed's remarks about science education and how if you start off learning with the magic of living things, you end up with a very different perspective on science and what counts. So I'm all in favor of rearranging things so that you have that interaction with the natural world at the outset. So the really interesting aspect of this population and impact question is that scientists have looked at how you could feed 9 billion people and actually do it without destroying another square inch of nature through a combination of improving agricultural productivity in certain situations, reducing food waste, which is 30% of all food on this planet is wasted, and 3, adjusting our diets more towards what our doctors are telling us to do anyway. Much less red meat, more plant products, and the rest. So it's not as though we can't actually achieve this, which would go a long way towards making half-Earth possible. We have to figure out how to implement it. It's not impossible. We just have to figure out how to implement it. And so I think the whole half-Earth effort has to go on 2 tracks. One, full blast, adding sort of to the nature estate under protection, but simultaneously working at the drivers that otherwise would make it really hard to achieve that. So whether it's agriculture or the wrong kinds of infrastructure, heedless development patterns, I think we have to work on those at the same time.
What about the politics? I mean, this isn't going to happen, setting aside half the earth for nature, unless we have a political will, correct?
Well, political will is really important, and you have to do a lot of work to get there, but you'll never get there if you don't try. And the thing that's so refreshing about the half-Earth idea is that when people hear about it, well, yeah, that sort of makes sense. There'll be a whole bunch of people say, well, why should nature have anything? But, we'll work on those. But there are a lot of others who, well, yeah, why not, right? So I think what's so great about half-Earth is it's actually begun to change the discussion. And it's incumbent upon each and every one of us to move that along as rapidly as possible.
Well, I'm going to ask you probably the toughest question I can think of is, like, what can everybody in this room do?
Well, one thing is you can make sure your elected officials understand these issues and that they really count with you, and that translates into all different kinds of ways they vote. But every one of us can be involved in protecting nature in one way or another. Everybody can be involved in planting trees to take some CO2 back out of the atmosphere. Everybody can be involved in restoring a wetland. There's plenty of hands-on things you can do, and the fun thing about most of them is they can be family exercises. And kids love to get mud between their toes.
John, what would you suggest for people in this room?
Well, I alluded to Martin Luther King. I'll now hide behind Mahatma Gandhi, who said, first they ignore you, then they laugh at you, then they fight you, then you win. Again, I said this before, but I think it bears repeating. I spend most of my time now traveling all over the country, talking mostly to young people. In 50 years, it's been 50 years since I saw anything approaching this level of energy and drive. And when that happened 50 years ago, what came out of it was the women's movement that transformed this country, the environmental movement that transformed this country, and the civil rights movement that transformed this country. Those things happened in that same range. That level of energy is there right now. I hate to quote Glenn Beck, of all people, but I'm going to. Glenn Beck, a couple of years ago, he was giving talks to crowds as big as this, probably not the same crowd, but big crowds. And when people asked him what to do, he said, well, that depends on whether you really want to do something or not. If you just want to hear me talk, sit there and listen. But otherwise, you need to run for office. That's what he said. And I'm sorry to report to you that his message seemed to carry a lot of weight. And, we all get tired of hearing, sometimes you despair, I admit, of the political system and of making change happen. But I think we are at a moment, an extraordinary tipping point in this country, and I don't know which way it's going to go. But I know it's going to depend on what people do, whether people can take this anger and even rage that they feel right now and translate it into concrete action. And in terms of what that action is, there's an old saying back from that earlier era: if you don't like the news, go make some of your own.
Edward Abbey said the antidote to despair is action. Paula, should we open it up to questions from the audience? Yeah? Yeah, I'd love to hear. Do we have microphones? Yeah, I think they're right over here. If anybody has a question for anybody here, please don't be shy. Okay, we're lining them up already.
I got one. What's your working definition of saving a habitat? What does saving half the world, half the earth look like?
Would you repeat that to me? I'm sorry.
What is your working definition of saving half the earth or saving a habitat?
Because I'm thinking, like, you think of oceans and water moves around, for instance. So it's a lovely image, but I'm wondering more specifically, are you talking about putting half of land masses into reserves, or is it a metaphor?
No, it's not a metaphor. It is literally the case. Of course, what we mean is half the area on the land and half in the sea. As we choose the sections and face whatever social problems connected with them, and I think those are soluble. In fact, I've gotten very little criticism or resistance about what impact this will have on people, because we're going to make, I think we could make it land into reserves in the way the national park system has succeeded in doing it. And for example, it's a national natural landmark system. You don't take away property rights. You actually improve the rights of indigenous people and the like. And by choosing judiciously what areas in both the land and the sea, in the case of the sea, the open sea, you could close fishing for the entire open sea. That's 50% right there. And we've been able to find 2 studies have shown that if the open sea were closed for fishing, that the total productivity in the territorial waters of the 150 nations that have a coast would actually grow because of the nursery and rapid dispersal, nursery function and the rapid dispersal of the open sea. So I think by just using a little common sense and being judicious in selecting the areas, many of the best areas that are available are the ones that have the most diversity and the lowest human population. I've been around the globe, mapped a number of times, and it becomes increasingly apparent to me that this is not going to be a big problem if people are willing to do it.
When you talk about our going home and getting our representatives involved or to buy in, and even other people at home, like I'm thinking about going back home, explaining this to my husband, to friends, to other people that I talk to, and they'll ask very pointed questions, and I'm not a science professional. Does the Half Earth Project have information online? Do you have things that we can look up statistics that we can give them. We need to be armed with easy to pass on facts that we can give our representatives, even that we can, so we can have intelligent conversations at the dinner table, on Facebook, all of that. So is that information available through the Half Earth Project?
I think the answer is yes.
Okay.
Start with a website. The book is also quite readable.
Oh, definitely. Yes, I have done that. Yeah. Of course.
If I might just add an example of one of the stories, not in the book, but I think it's an important, interesting one. There's an area in coastal Mexico where it's the fishing rights are dispersed per family, and the families pass it down. Well, people are smart, and people in that area have entirely voluntarily decided to have one child each. And the reason they do it, nobody's telling them to do it, is because they go, well, we can pass this right along to our son or daughter. And that way, you have a situation where the ecosystem is being preserved, people have a decent livelihood, and they're making the free choice that they want to make to be successful in that. That's a pretty good example of one of the non-monetary, if you will, non-acquisitional ways that you can set aside and preserve resources.
So there's another important piece to this, which is restoration. So there is like in Montana, there's a project there called the American Prairie Reserve, which eventually will be 5% of Montana, which happens to be our 4th largest state, and it will be restored back to original condition with wolves and bison and black-footed ferrets and everything else. So it's not just going for the remnant pieces, it's also doing some restoration. And when you do that, you also reduce the amount of climate change that we're going to face, because when things grow, they all are built of carbon and they're taking it back out of the atmosphere.
Yeah, first off, let me say thank you to you, Dr. Wilson, because as a microbiologist, I can appreciate those references to the bacteria and the viruses. Seeing that added to the discussion empowers me and makes me happy. Also, I appreciate the referencing of Dr. King and Muhammad Ali in your comments, John. And then finally, with what we just heard about restoration, we have happening just right down the street at the American Tobacco Trail, a good friend of mine, Justin Robinson, who's a forester and a musician of note, is establishing or revisiting, planning a prairie environment that's more like what existed here 5,000 years ago, with species along those lines. But my question is, for a whole week, I will be taking college undergraduates on a week-long excursion into southeastern North Carolina relative to environmental justice, starting this Sunday. We will be visiting Navassa, which is a small black community southwest of Wilmington, surrounded by 4 Superfund sites. We will be going to Lumberton, which was hit by Hurricane Matthew. We will be going into Wilmington and doing some things much like Habitat for Humanity, and to Duplin County to look at the damaging effects and impacts on people living in Duplin County, which has been inundated with hog farms. As I travel and engage in reflection with these undergraduate students, what sort of message can I give them directly from each of you as we reflect on what we're about to do for a whole week, especially as it ties in to Half Earth, especially as it ties into especially challenging places where people of color have been pretty much, as I just said, surrounded by environmental depredation. I just want to have something wonderful to tell them, inspire them, and get them to do more.
So if I may jump in on that, environmental justice is an incredibly important issue. And what you'll be showing them is basically environmental injustice that occurs at the moment, but environmental injustice also can occur through time. So to the extent that we run down and degrade the biology of the planet, or we don't, is a huge environmental injustice issue because what it means for future generations.
Gloria Feld, who's the former national president of the Planned Parenthood Federation of America, was the keynote speaker at a program we did for hundreds of college students several years ago, as we do every spring. And she talked about traveling to a clinic in Mexico. And she saw a young woman there, not 20 yet, who had, as they say, one in the belly, one in the arms, and one in her hand. And this young woman was, for the first time, visiting a family planning clinic and learning about possibilities. And I'll never forget what Gloria Felt said. She said, "I saw a revolution in her eyes that day. I saw a revolution in her eyes." Things that often seem so commonplace and so obvious. I talk a lot, traveling around the country, about family planning. You can feel the air go out of the room. It just seems like such a routine thing. But there are things that seem perhaps so small for so many of us. But if we pay attention to them and understand how transformative they can be to people's lives. I worked at EPA, and we worked on some environmental justice programs. One of the things that people in the city of Chester in Philadelphia, just south of Philadelphia, which is a predominantly minority, poor black community, had to deal with was just the fact that it smelled terrible all the time because of the refineries. And one of the challenges that EPA had there was they said, and these were really dedicated people, said, we don't even know how to measure that. We don't know how to do that. But some of the things that many of us take for granted, just being able to walk out the door and have it not smell terrible, or just being able to go to a pharmacy to pick up birth control, are so far beyond the reach of people. And yet these are things that are achievable and that don't necessarily require extraordinary new technological breakthroughs.
Yeah, I mean, the black communities get hit the worst. I mean, if you look at the refineries, they're set aside in these neighborhoods where, you know, they target places where they can get away with this. So, I mean, we were hearing some of the presentations today, earlier in these sessions. It's about organizing. It's about organizing people in your churches, your communities, however you get together. We have to do what they did in the Civil Rights Movement. You know, we have to take cues from what worked in the past and apply it to the future. And we're going to have to band together, however we can, in our communities and conquer this. I mean, I don't know about the other people in this room, but every day I wake up and I'm just so upset about what's going on with the EPA. I mean, we need a strong EPA. Now is not the time to defend it. 30 years ago, I was working as an intern in LA, and it was so foggy every day going to work, I couldn't see the cars in front of me. And then one day, the Santa Ana winds came through and cleared it out. I could see mountains in my rearview mirror. I thought it was the most surreal experience. I didn't know there was mountains around LA for a month. And I forgot about this until they announced that they were going to be cutting funding back about 20%. I was in Beijing 2 months ago. I never went out all day. It was a sunny day. You couldn't see the sun. And that's what we're looking at. When people start to forget what we came for, we have to fight every single day of our lives for what happened. You know, this Clean Air Act happened a while ago. So did the Civil Rights Act. We have to keep on fighting and fighting and fighting so the young generation does not forget what we came this far for. I'm convinced that we can stick together. This next election is going to be a completely new life, but we have to. Everybody in this room has to be committed to changing what's going on, because we can't sit still. We can't.
Thank you. If I might add
Please.
one word, we can't click our way to success. It's not going to happen. We've got to look people in the eye. It's going to take face-to-face contact. There's a cognitive scientist named Robin Dunbar in England who's done some very interesting work around primates and found that the size of the group of any primate corresponds to the size of its cerebral cortex, and that the basic human group is about 100 to 200 people. If you think about the example he uses is if you happen to go into a bar, if that's where you were, and you saw somebody sitting there, how many people would you just go up to and just start talking to without having to go through any kind of introductions? There is this kind of group size for humans that seems to be related to the size of our brains, and I think it's a question of finding that group of yours, and please don't email them. I mean, that's fine, but we don't even collect vast numbers of emails anymore because who needs more email right now? I mean, it's a way to learn about things, but it's not a way to change the way people think or to give them hope or to inspire them. We can only do that, I think, face to face, and I think that's the key to making the kind of changes we need to make.
In defense of clicking, I mean, the thing is, we do a lot of petitions where I run this little organization called the Oceanic Preservation Society. We got 165,000 signatures online for UPS. These are just people. UPS was importing shark fins, and sometimes illegally, sometimes illegally. Legally, sometimes illegally. But what we did is 165,000 signatures. We got that company to ban that from, once you have 10 or 20,000 emails or, fire emails coming in, you get the notice of the PR department, human resources, they start to take notice. So I've seen change happen, by people banding together with just clicks. And I know Laura Seidel's son is working on some great apps to get a hold of your signatures, get a hold of your your congressmen, your senators, and reach out to them and pummel them with what's going on. Obviously, pick up the phone's the best thing to do. People, they get scared of that. The politicians don't like to answer the phone. But when you start to get tens of thousands of calls, then you start seeing the change happen. They're cutting the phones. Oh, that's right, in this state. Oh, yes, we have some more questions to get through.
Please elaborate on how a plant-based diet would save the planet.
Plant-based diets to save the planet. Yes, that's the next film I'm working on. Actually, I'm doing a film that's executive produced by James Cameron. It's about super athletes and nutrition, and all protein comes from plants. We just cut out the middleman, and it's you can save resources an order of magnitude less land if you're actually eating what you normally would be feeding, let's say, a cow. The world's strongest guy is a vegan. World's most accomplished ultra runners are vegans. 2 of the top 10 boxers right now are vegans. There's a couple ultimate fighters that are, these are tough people. There's a oxymoron that vegetarians hit like pussies. I mean, anyway, it's a great way to go. It's a cleaner source of protein. You can it's like what the doctor's been saying for decades now. If you want to clean out your arteries, we just did this. We just gave 30 firefighters in Brooklyn who all had high cholesterol. There was 30-year-old kids that had cholesterol in excess of 300 points. We gave them a plant-based diet for 7 days. Whole Foods gave us 2 bags of groceries for each one of those firefighters. They came back 7 days later, plant-based diet. Average weight loss was 6 pounds in 7 days. The average cholesterol reading went down 30 points. One kid that was 35 years old had over 300. He had a 106-point drop in 1 week in cholesterol. If you want to save the planet, start changing what you're eating. Put it on your plate 3 times a day.
Yes, sir. Thank you.
I first wanted to thank you all for being here. I feel so honored that I can sit here and listen to you all talk, and it's also a really great break. I have a lot of exams going on, and I could be studying, but this is a whole lot better. So I have a question about Half Earth. Is there a formula to it? Do we need a certain amount of deserts, a certain amount of tundras, a certain amount of rainforest to make this work? Or can we just save any old half of the earth?
Do you want to talk about hotspots?
Do you want me to repeat the question? The question was, is there a formula to half Earth? Do we need a certain amount of desert, a certain amount of rainforest, a certain amount of ocean, or is it fairly random? If that's a fair way of saying it.
Yes, sir.
Detail. I think we'll work that out. I mean, as time goes on, I think, we'll make sensible decisions about what is the most valuable kind of real estate to put in a half Earth like this, and that we will, I think, have enough of the richest habitats available to cover a good part of that 80% that we want to save. And we're at the beginning stage now of mapping what could be the areas. And I'd like to have this such a popular thing to do. I mean, it's a matter of pride that countries could have a substantial amount of their country designated that. It won't have any effect. It could promote economic development to have it. When I gave this, I spoke on this to the United Nations, a meeting of the environmental leaders during their last meeting of the UN, and I met acclamation from the leaders. And the Minister of Environment of Brazil came up to me and said, we already have 51%. And a large part of that is Amazon forest. So to me, this is, because it's the right thing to do, and it's good for the country, in the long run, to save its resources like this. We'll be able, I think, without an awful lot of friction, if there's sufficient mood to do it, be able to make the sensible kinds of decisions about what parts of the land. I won't be comfortable with making all of Antarctica a part of the reserve, It only has nematodes and bacteria.
So one of the really remarkable things you just referred to, Ed, is what has happened in protecting the Amazon. And I've had 51 years of going back and forth to the Amazon, and when I first went, there was one highway in the entire Amazon, an area as big as the 48 states, and there was only one national park in Venezuela. And today, the Amazon, which is made up of 8 countries, and French Guiana is now slightly in excess of 50% under protection. So that's pretty astounding.
So I had a quick story and then question. I went to a nursery to find myself a plant for my home office and realized that I wanted to move my office to the nursery. My question with the half of the earth that is for nature, how are we going to incorporate nature into the everyday experiences of individuals? I know a lot of people who are moving out to the country and not into the city for that exact reason. So how can we make cities better environments for both nature and people?
I mean, I don't know. I'm a big fan of getting rid of cars. You go to Europe and people start talking to each other when you have these big promenades. In Colorado, in Boulder, where I used to be from, they set aside a couple streets and people can just walk, and that makes a big difference because it just changes the way when you're using your feet to get around instead of a car. That's huge. Or with bikes when you can do it in the weather. I mean, it's a huge way to go. Guys?
We're within a few years of having truly cost-effective vehicular battery storage that'll work for everybody. And we seem to be moving in the direction of autonomous self-driving vehicles. That's either going to make things a lot better in cities or it's going to make things worse, depending on which way it happens. If those cars are privately owned, then, believe it or not, people are going to sit in their car, have it drive them to work, and then to save on the parking fee, they'll just send their car home. On the other hand, if you have autonomous self-driving fleet vehicles, according to researchers at Stanford, we can go from 3%, 2 to 3% current automotive utilization up to 50%. Not more driving, more efficient use of vehicles for commuting purposes and then in between for delivery. What that would mean, for example, is that you would virtually eliminate the need for any on-street parking in cities. Imagine how that would change cities if you didn't need any of that. And imagine if you had dedicated bike lanes in every single city. There are all kinds of opportunities that are right on the horizon, and that's just one of them.
Over here.
As a follow-up to the young lady before me's question about what half of the earth do you save, how will climate change enter into those decisions? Do you, for instance, save 1,000 acres of marsh in Terrell or Hyde County in North Carolina, which will be on the water in 50 years? Do you save 1,000 acres of a boreal forest in Mitchell County in North Carolina, and that ecosystem is collapsing now and will collapse no matter what we do? We are entering a profound time of climate instability that just sea level rise will change the geology of the North Carolina coast. If the ice disappears again, the coastline will be where the fall line is, and that's about where I-95 is. So this is a time of profound change, which human history we've never seen before in human history. How does that enter into these kinds of decisions about what you save and how you go about saving it?
So I think I probably should take that on. So I've been working on the interaction of climate change and biodiversity for 30 years, just finishing up a third book on it, which will have a foreword by the distinguished Professor Wilson. And there's no question you can already see the fingerprints of climate change on nature all over the world. The issue really is how much climate change we will allow to happen and what that might mean. And one of the great things that came out of the Paris meeting was, instead of talking mindlessly about a 2-degree target, they began to talk about less than 2 degrees or 1.5 degrees, which has been a concern of mine for some time. Now, if you look at the numbers at the moment of emissions and all the rest of it, and all the projections, it sort of looks hopeless. But we're in a process of change, so those trajectories can bend over time. But imagine if there was a way that we could take maybe even 0.5 degree of potential climate change back out of the atmosphere before it actually happened. And as it turns out, there's a significant amount of excess CO2 in the atmosphere that's there from centuries of destruction and degradation of ecosystems. And if we were to, really get at restoration at scale, we could probably take 0.4 to 0.5 degrees of potential climate change out of the system before the radiant heat is trapped. That would add a lot to Half for Nature, just through the restoration. It would limit the amount of climate impact. And it would, I think, transform everybody's understanding of how the planet works, that it actually works as a linked physical and biological system, that it is a living planet, and it makes all sense in the world to treat it that way. So I think if we can sort of take on climate change and what ecosystem restoration could mean, it could be really very reinforcing of what we're trying to do here with Half Earth.
Hi, so this is the first time I've been brave enough to get up and ask a question at one of these. So my question is based on two assumptions. More people at the proverbial table means more ideas, and children are inspired by people that look like them. So I've been to a lot of these, and this might sound blunt, but the keynote speakers are always white men. So how do we get more young people, more women, more people of color involved in the environmental movement?
Population Connection is one of 36 national environmental organizations that form a loose group called the Green Group that includes most of the organizations that people are familiar with. The CEOs meet 3 times a year in person, no substitutes, and there is only one standing item on the agenda, and that is the very question that you have raised. I'm pleased to say that over the last few years, the group has become more reflective of the diversity of the country in terms of the number of CEOs, people of color, women, and of that sort. It's not an easy challenge, and I think one of the things that we've all learned is you can't do it through checkboxing. What you've got to do is create real pathways to leadership for people who come from different backgrounds, and I don't think if I had some magic answer for that, I'd tell you what it is. I think it's a question of looking in non-traditional places for voices. It's a question of recognizing that cultures of organizations often have kind of inherent biases built into them that people don't even know are there. And if intentions count for anything, I certainly think the national environmental movement is trying to move in the right direction and trying to focus attention and resources on things like the poisoning of children in Flint and other things of that sort. But at every meeting like this, there should be someone asking that question, so I'm glad you did.
So it's an incredibly important point, and I couldn't agree with you more. I'm happy to report that the course I teach at George Mason, a university that has 120 countries represented in the student body, that is an incredibly diverse group of students, and 80% of them are women. And as I like to say, they don't call her Mother Nature for nothing.
So again, I want to thank all of you for being here and presenting a topic that is the most essential and important topic I can imagine, because it affects all of us in our physical being and our spiritual being. And when people frame the issue or the story that it's man versus nature, that is totally erroneous. We are nature. We are a part of nature, and we need all of these species in order for us to thrive. So I'm looking at this as an environmental educator. I've taught children for about 30 years in outdoor settings, but also in classrooms, and I am feeling so much urgency about this that I am encouraging you folks to please take it outside of the classroom. You seem to really understand how to do it in the classroom, but I think that this should be the most inclusive movement that we can have. Nobody's exempt. You're not too old for this. You're just the right color for it. We need everybody to be involved in this. And so I'm thinking about this as a sort of an environmental or ecological literacy that needs to happen. And it needs to be sexy and fun. This is what motivates people. So I'm thinking about using technology and social media as a way to contact as many people as possible and spread these memes and getting people thinking differently. The other thing that I wanted to say is, I know we're talking about the terrestrial part of the globe, but let's not forget the oceans. And something that I've learned recently is that phytoplankton are fantastic natural mechanisms for carbon sequestration. We always think of our terrestrial forests, but the phytoplankton floating, that's plant material floating freely in the sea, that this is a wonderful way to capture carbon, and then it goes up the food chain, and then when the bones of those larger animals die, it keeps that carbon captured for over hundreds of thousands of years. I've even heard up to 1 million. So I know that for our purposes right now, we're talking about the earth, the land mass, but let's also talk about the sea.
Well, I'm very excited about the oceans. I run the Oceanic Preservation Society. The problem with carbon in the ocean, it's become about 30% more acidic since the industrial age. It's going to do another 30% by 2050. If you do that, we're going to be losing all the coral reefs. The coral reefs are being assaulted right now. You can save those hot spots all you want, but the truth is we're acidifying. We just lost a year and a half ago, we just lost 22% of the Great Barrier Reef, just died off. That was captured in a really wonderful film, a terrifying film called Chasing Coral by Jeff Orlowski. I go to the United Nations right after this. We're going to be lighting up, we're making a proposal to light up the building, the whole building this time. Racing Extinction, the film I just did, we lit up the spine and the General Assembly building. This time, and we want to light up the big flat face facing with the New York skyline, 39 stories. It'll be the biggest billboard in the world. Trump Tower will be in the background. And we want to show these before and after pictures, because Jeff did that in his film. He showed, here's the Great Barrier Reef looking like a teeming, it's like one of your drawings, Dr. Wilson. It's like a teeming city full of life, vibrant with these incredible life forms. They're lit up like jewel boxes. Then you see 6 months later, they turn white, and then algae comes over, and they're dead, and they don't come back. Once previous, Stuart Pym probably verified this, previous to every mass extinction, we lost the coral reefs. That's what's going on right now. I don't think there's any issue bigger in the world. My friends in paleontology say that when we look back at the Industrial Revolution into the 21st century, World War II, in comparison to us losing biodiversity, will be a footnote in history. So this is our time. The people in this room, this generation is the only generation that can really fix this problem. There's no other people that we can look to. Yeah, we're going to have to hand it off to our kids, but we're the ones that are going to really set it off. If we don't turn this around in our generation, it's not going to happen. And that, to me, is not despair, it's empowerment, because that means there's nobody else but us. Thank you.
It is my understanding that the technology behind genetically modified organisms has the potential to restore genetic integrity to species that have lost their genetic identity from years of artificial selection, or, in this case, gradual dwindling of individuals from human impact. Is there any validity in this technique to restore organism populations, like the vaquita, where it is estimated that only 60 individuals remain in the world? Do you believe this technique to be valid in restoring populations that may be too far gone in terms of genetic viability? Is it time for serious human intervention?
Boy, are we talking, I don't think I quite heard that. You're talking about bringing back creatures that are extinct?
No, genetically modified organisms in terms of...
I'll let one of the scientists handle it.
Well, I'll give you my answer, which is genetically modified organisms is about a technology. And technologies basically are neither good nor bad. They're neutral. It's how you use them that makes the difference. And in the case of genetically modified organisms, if we were able to design mosquitoes in Hawaii that would eliminate the bird malaria and take the pressure off the native Hawaiian honey creepers, I think I'd probably vote for that. But I think in this case, it's the kind of thing, it's so new, you just have to be really careful.
I think we have time for one question, then just from the side. Sorry.
Doctors Wilson and Lovejoy, you speak to the importance of exploration in helping young people to both learn and care about science. Do you have any thoughts on the role of citizen science in making the kind of research and awareness possible that would make half-Earth effective?
I think the question had to do with the role of physical science.
No, citizen science.
Citizen science. I couldn't hear it either, so thank you. I was trying to figure out what the question was, but the role of citizen science in encouraging exploration and putting children closer in touch with the natural world. Is that close?
Yeah, that's pretty close.
Thank you.
Sure. I'm glad you brought up citizen science, because this is the domain in which contribution from citizen science is real. People who go out into an area and participate in biodiversity surveys, and it's a very interesting thing to do, to see how many species of butterflies you find, or looking for a rare species that is known there, or just collecting and photographing organisms that you find is an integral part, can be an integral part to making the studies that we have to make at the first line of investigation of the distribution of organisms and species. And so that's very good science. And to have families doing it with the one field in which the kids can beat the adults is healthy in every conceivable way.
All right, I think that's it. I think, Ed, if you could introduce our special guest. I think we're...
I hope, with a guest and a luminary of this magnitude, the proper thing for me to do would be to get to that platform, to get to that lectern, and stand erect in order to make the statement. But I hope you will forgive that due to my debility, recovering from a fractured hip, that I'm going to be allowed to introduce this remarkable man, seal seated. It's certainly an honor for me to be the one to introduce to host a person of this achievement and importance in American culture. He is certainly an authentic legend and icon for broader American culture, and he has been probably the most decorated person in the music industry, I think, alive or ever was alive, with enormous recognitions that were which deserved. I think 12 Grammys can be mentioned in passing. He is known to us all, and it's become my special pleasure to get to be his friend and also to have him join in supporting the basic idea of biodiversity conservation as one of the necessities of our future civilization and all of the amenities found therein. It's my pleasure then to call to the stage Paul Simon.
Let us be lovers, we'll marry our fortunes together. I've got some real estate here in my bag. So we bought a pack of cigarettes and Mrs. Wagner pies, and we walked off to look for America. Kathy, I said as we boarded a Greyhound in Pittsburgh, Michigan seems like a dream to me now. It took me 4 days to hitchhike from Saginaw, and I've come to look for America. Laughing on the bus, playing games with the faces. She said the man in the gabardine suit was a spy. I said, be careful, his bow tie is really a camera. Toss me a cigarette, I think there's one in my raincoat. No, we smoked the last one an hour ago. So I looked at the scenery. She read her magazine, and the moon rose over an open field. Kathy, I'm lost, I said, though I knew she was sleeping. I'm empty and I'm aching, and I don't know why. Counting the cars on the New Jersey Turnpike, and they all come to look for America. All come to look for America. All come to look for Thank you so much. Yeah, it's a pleasure for me to be here and to join you in support for the thoughts that Ed has proposed in his book. It's a galvanizing book. I'll tell you how we met. Ed and I met about 8 years ago at a TED conference. He was receiving the TED Prize, and he was working on an encyclopedia of all living organisms, which he completed in the following year after the prize. And when he spoke that night, he said something that was so powerful to me that it stayed with me. What he said was, we have the opportunity to make this planet a paradise by the next century. We will be in paradise, but we can lose it too if we don't do the right things. And it was so inspiring, the thought of where we could, realizing that yes, we are in a paradise, and it can be even more so if we are the custodians of our planet and make it such. So last spring I was doing an interview because I was on tour, and I was talking about Ed and what he said and how it had stayed with me. And Paula Ehrlich, I guess heard the interview, and she contacted me, and Ed and I reconnected. And although I had visited him up in Harvard years back, and when he showed me the hundreds and hundreds of drawers of ants, all with a little card and the Latin name and the pin stuck through their little hearts. So anyway, we met again. And I said, well, I don't know what I can do. All I can do is I can do a concert or a series of concerts, and I can talk to people, but otherwise the problem is so enormous. I don't know. That's what I do, So I said, okay, I'm going to do a tour. I'll set up a tour next June, and I'll take all the money from that are the profits from that tour, and I'll give it to the foundation, and we'll let that be a beginning. Yeah, I think you all know that we're at a unique moment in time, and it's our generation that has to seize this moment and make it happen now. We can't pass it on. It's our responsibility, and our time is now. And the thing about it is, if we attempt to solve these enormous problems with an enormous amount of energy that we can generate by working together, we will solve these problems. And it's been a tough year and a half of anger and divisiveness, but that energy can be dispelled with a more powerful energy of all of us, coming together. And I would hope that what happens after tonight is you very bright people will think up ways of contributing to the various organizations or causes that have been spoken of tonight, or forming your own, or just finding out about it and lending your real support. I mean, of course, writing a check is good, but actually getting in there and doing the fight. I think we're going to win. We have to win. So I'm just playing a couple of old songs here. I'm sitting in the railway station, got a ticket for my destination. On a tour of one-night stands, my suitcase and guitar in hand, and every stop is neatly planned for a poet and a one-man band. Homeward bound, I wish I was homeward bound, home where my thoughts escaping, home where my music's playing, home where my love lies waiting silently for me. Every day's an endless stream of cigarettes and magazines. Each town looks the same to me, the movies and the factories, and and every stranger's face I see reminds me that I long to be homeward bound. Oh, and I wish I was homeward bound. Home where my thoughts escaping, home where my music's playing, home where my love lies waiting silently for me. Tonight I'll sing my songs again, play the game and pretend. But all my words come back to me in shades of mediocrity, like emptiness and harmony. I need someone to comfort me, homeward bound. I wish I was homeward bound, home where my thoughts escape me, home where my music's playing, home where my love lies waiting silently for me, silently for me. Oh, thanks. In case I want to drink water. Also, I think I'll give the $100,000 for tonight's performance too. I'll give it. I'll throw that in there. Well, half of it anyway. Yeah, the mama pajama rolled out of bed. She ran to the police station. The papa found out, he began to shout. He started the investigation. It's against the law. It was against the law. What the mama saw, it was against the law. Yeah, the mama looks down, she spits on the ground every time my name gets mentioned. Papa said, oh, if I get that boy, I'm gonna stick him in a house of detention. Well, I'm on my way. I don't know where I'm going, but I'm on my way now. I'm taking my time, but I don't know where. Goodbye to Rosie, the queen of Corona. I'll see you, me and Julio, down by the schoolyard. See you, me and Julio, down by the schoolyard. Whoa, in a couple of days, gonna take me away, but the press let the story leak. Now when the radical priests come to get me released, we was all on the cover in Newsweek. Yeah, and I'm on my way. And I don't know where I'm going, but I'm on my way now. I'm taking my time, I don't know where. Goodbye to Rosie, the queen of Corona. I see you, me and Julio, down by the schoolyard. See you, me and Julio, down by the schoolyard. See you, me and Julio, down by the schoolyard. A poor boy, his story seldom told, squanders his resistance for a pocket full of mumbles, such are promises. All lies and jests, still a man hears what he wants to hear and disregards the rest. When I left my home and my family, I was no more than a boy in the company of strangers, in the quiet of the railway station, running scared, laying low, seeking out the poor quarters where the ragged people go, looking for the places only they would know. Lie, la, lie. La 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 la. Asking only workmen's wages, I come looking for a job, I get no offers. Just to come home from the wars on 7th Avenue. I have to tell you something. I have to tell you something that happened to me. I was walking down Central Park West in New York, and a woman with a toddler stopped me, and she said something like that. She said, "You are my son's favorite singer." And it's about this high. I said, "Really? That's so nice. That's so nice to hear." And she said, "You'll never guess what his favorite song is." I said, "No, I never will." She said, "It's The Boxer. But when we get to the part where they say, 'The whores on 7th Avenue,' we change it to 'The toy stores on 7th Avenue.'" That's a better line, I said, you know. La la la. La 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 la. Toy stores. La 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 la. La 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 la. La 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 la. And I'm laying out my winter clothes, wishing I was gone, going home, where the New York City winters aren't bleeding me, leading me, going home. In the clearing stands a boxer, a fighter by his trade, and he carries them reminders of every glove that laid him down or cut him till he cried out in his anger and his shame, I'm leaving, but the fighter still remains, he still remains. Sing la la la, la 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 la, oh, la 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 la, la 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 la. La 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 la. Thank you so very much. Thank you. Oh, you think I'm taking requests? Hello, darkness, my old friend. I've come to talk with you again, because a vision softly creeping lifted seeds while I was sleeping, and the vision that was planted in my brain, it still remains within the sound of silence. In restless dreams I walked alone, narrow streets of cobblestone, beneath the halo of a street lamp. I turned my collar to the cold and the damp, when my eyes were stabbed by the flash of a neon light that split the night and touched the sound of silence. And in the naked light I saw 10,000 people, maybe more, people talking without speaking, people hearing without listening, people writing songs that voices never share, and no one dare disturb the sound of silence. Fools that I do not know, silence like a cancer grows. Hear my words that I might teach you, take my arms that I might reach out to you, but my words, like silence raindrops fell and echoed in the wells of silence. And the people bowed and prayed to the neon god they made, and the sign flashed its warning, and the words that it was forming said, the words of the prophets are written on the subway walls and the tenement halls, and whispered in the sound of silence.